Okay, today, my people, we're writing equations from secants and cosecants and cotangents and tangents, right? And part of this is doing the identification of the period and the asymptotes, right? Because all four of those other trig functions, secant, cosecant, tangent, cotangent, they all have asymptotes. Okay, so we're going to be identifying the periods and the asymptotes for each of these graphs. So the first thing we're going to try and identify is the period. Okay, so a period is how long does it take to do one complete cycle. And unfortunately, that means different things for different graphs. So a tangent or a cotangent graph has one windmill, quote unquote, and that's its entire period. Okay, so from one asymptote to another asymptote, this is your period for tan and cotan, okay, which is traditionally pi over something, right? So our standard period for tan and cotan is just pi. Okay, but then if we have a secant or a cosecant graph, the standard period for that is one entire u going up and a u coming back down. So in other words, 3 asymptotes. So if we have a cosecant graph or a secant graph, which is 2 pi over b, right, we need an entire up u and we need an entire down u. So there's different amounts of the graph that we need for different graphs or for different functions. So looking at our function here, okay, would you guess that this is going to be a standard sine, cosine, cosecant, secant, tangent, or cotangent? Yeah, it's a very interesting class. Yes, I would indeed guess that this would be a tangent graph. Okay? A tangent graph because it has the attributes or characteristics of a tangent, which are low on the left and growing continuously, increasing from left to right. Okay? So this would make most sense as a tangent graph. Excellent. So let's identify our asymptotes. So our asymptotes are in between every one of our graphs. Right? Your vertical side of your graph will not touch your asymptote. So it looks to me like this would be a good distance, right, to represent the period. It's the vertical asymptotes that divide your graph. Okay, vertically, there's no horizontal asymptote to a tangent or cotangent. So this would represent one period from one asymptote on the left to another asymptote on the right. So we got to kind of figure out how far is that from one asymptote to another asymptote. So let's count our lines. Okay, so if we start at this asymptote on the left, we count 1, 2, 3, 4, 5, 6. 6 lines. Okay, 6 vertical lines make up one period. Okay, which is not your answer. We're just trying to figure out what is the answer. So how far, if we go back to our y-axis, and if we go 6 over, how many units is 6 lines? 1, 2, 3, 4, 5, 6 gets me to pi. Okay? So looking at the way that we have labeled, or that this graph is labeled, 6 lines equals pi units. So if my period is 6 lines long, that means my period is pi units. So our b value, this is what we need for our equation. The b value is always found by doing pi, your standard period, divided by whatever our period is. So our period is pi. So pi divided by pi means we have a b value of 1. Okay, so in other words, we're not going to see a number in front of your variable when we get down to writing the equation with a b value of 1. Okay, maximum and minimum, these should be pretty easy since the graph goes all the way up to and forever. It has a maximum value of infinity and a minimum value of negative infinity. Okay, which should make sense because the range for tangent is all real values. Okay? So if it's a tan or a cotan, we're always going to have infinities, right? They don't have maximums or minimums. because the y values are always increasing to the right and always decreasing to the left. So there's your all reals. Okay, the next thing we're looking at is your vertical slide. Okay, so this is kind of tricky depending on how good your eyeballs are, because we want to try and identify the zero. Right, the zero of your graph is where it crosses your midline, or where that graph crosses your traditional x-axis. Okay, and looking at this, I might guess that this is my middle point. Right, these would be my zeros. It divides your graph exactly in half. Right, so it's 1, 2, 3 units from the left asymptote and 1, 2, 3 units from the right asymptote. Okay, that 0 point is always going to be exactly in the middle of your asymptotes. So this would be a pretty good guesstimate as to where it's going to be. So how many units above the x-axis are each of these 0 points? Okay, this is your vertical slide. So I would count that this is 2 units above the x-axis. Okay, so our zeros have been moved 2 units up. So this has a vertical slide of 2 units up. Every time we're doing a translation, we need to have 2 parts. We need to have a distance part, and we need to have a direction part. So this does not have a vertical slide of 2 units. Okay, that doesn't give us enough information. It's how far and in what direction. So this is 2 units up or 2 units down, right? So it's not a -2 if it goes down. It's 2 units down. Okay, so make sure you have a distance and a direction whenever we're doing these shiftings. Okay, so there's your vertical shift. Now the phase shift. So we have to think about, where does our traditional tangent graph cross your y-axis? And that is exactly on it. So we're trying to move this 0 point. How far has that been moved away from your y-axis? Okay, so if we count, it's been moved 2 lines away to the right. Okay, this dot right here, this 0, is 2 units away from where it's supposed to be on your y-axis. So how many units is 2 lines, right? Because we're not lines. This is not pi over 2 lines. How far is each line? That's what we have to figure out. Well, if 6 lines equals pi units, then what does 1 line equal? If 6 lines equals pi units, then 1 line equals pi over 6 units. Okay? If 6 lines equals pi units, then 1 line equals pi over 6 units. You're just dividing this by 6, right, to figure out what 1 is. So if I go 2 lines and every line is pi over 6, what's pi over 6 plus pi over 6? Well, that's 2 pi over 6. And 2 pi over 6 can reduce to 1 pi over 3. So this is our phase shift. Each point has been moved pi over 3 units to the right of where it's supposed to be. Okay, so we have to figure it out. And you have enough information from your graph to figure that out. Now there's one more thing that's not on our chart, and that's, what is your dilation? Okay, because every one of these could have a dilation. So let's add that in. What is the dilation factor? Okay, so how we tell that? We go halfway between your 0 and your asymptote. Right? So 0 and the asymptote, halfway is right here. And where is that point in relation to your halfway? Right? So here it's 1 unit above. So this graph has a dilation of 1, which is your normal standard dilation. Okay, so in other words, it's not going to have any number in front of your trig word because your dilation is just 1. Okay, but that's that pi over 4. Right? Halfway between your 0 and your asymptote is where you put in your dilation or your amplitude. So this one is 1. So now we're going to put it all together. Okay, so we do dilation, right? Your amplitude is 1. And then our trig word is tan. Okay, we have a b value of 1. So that's 1x. Okay, so x goes in parentheses because we have a phase shift. The phase shift is pi over 3. And since it went to the right, what sign goes in my parenthesis? If my graph went to the right, that means I have a minus in my parenthesis. And then the last part is your vertical slide up 2 units. Okay, so the vertical slide goes last. Okay, so yes, that's pretty a lot of extra stuff. So we could just write tan of x minus pi over 3 plus 2. Right, that would be how you would see it if you were going to be doing a worksheet. It would say tan of parentheses x minus pi over 3 plus 2. All right, let's see if we can do that whole thing again with our second example. Okay, so here's your graph, right? Based upon first inspection, what type of a graph do you think this is? Which one of the 4 other trig functions? This would be a cotangent. Very good, a cotangent graph. Okay, this is one of the attributes of cotangent, is that it is an always decreasing function. So from left to right, the y values are getting smaller. Okay, that's one way that you can tell it's a cotan graph. Another way is that it has a y, or an asymptote on your y-axis. This is also something that the cotangent has naturally. A natural cotangent graph has an asymptote on your y-axis. Okay, tangent does not. Tangent goes through your x or your y-axis, where cotan has an asymptote there. Okay? So now that we've established it's a cotangent, we're going to look for our period, right? And one period is exactly 1 asymptote, or 2 asymptotes. So from here to here. So according to our graph, how far is that? That happens to be pi over 2. Okay, so from the left asymptote to the right asymptote is pi over 2 units. So this has a period of pi over 2. Okay, now if your b value is equal to, well, let's just do them. If your period is equal to pi over b, and we have pi over 2 as your period, then what is your b value? Your b value is going to be 2. So in your equation, when we write our equation, we're going to have a 2 as the number in front of x. Okay? Pi over b, that's how we find the period. So if 2 is your denominator, then 2 is your b value. Okay, cotan, a maximum of infinity, a minimum of negative infinity, because it has an all real range, right? Nothing is happening there. That should be surprising for a cotan graph. But now look at the vertical shift, right? Once again, we're looking for that middle period. So if we're 3 units from asymptote to asymptote, that means exactly at 1.5 is where we're going to find your 0. So here is a 0, there is a 0, everywhere a 0, 0. All my students have a farm, E-I-E-I-O. Okay, so how far has that been moved from your x-axis? Hopefully, since we're counting, it's been moved 1 unit in what direction? 1 unit down. So our slides and our shifts always need a unit and a direction. How far and in what direction? Okay, so this would be our midline, right? We would go ahead and sketch this if we were graphing. We'd put your horizontal in here representing your midline. So everything has been moved down 1 unit. Okay, is there a phase shift? Right, I would say no. Hopefully you would say no also, because we're supposed to have an asymptote on the y-axis for cotangent. This graph does have an asymptote on the y-axis, so there's not going to be a phase shift. Okay? Asymptote on y-axis. That is why there is not a phase shift for our cotan graph. Right? If this were going to be a tan graph, then yes. But it makes most sense to have a cotangent graph without any phase shifting. Okay? So there's no phase shift if we're going to write a cotan. So then let's put it all together. Oh, wait a second. Is there a dilation? That's our last question. Is there a dilation? So how we find the dilation is we go halfway between your 0 and your asymptote. Right, halfway between the 0 and the asymptote, and you go up. Okay, this is your dilation. Halfway, right, the 45-degree mark. 45 degrees is halfway between your 0 and your left asymptote, and we have a dilation factor of 1, right, because our point is just 1 unit above that middle. So in other words, we're not going to have a number in front of cotan, right? So we're going to have a 1 here, which we don't ever write a 1 as a leading coefficient. Okay, cotangent of, since we don't have an asymptote, we don't have to put parentheses, but I'm going to just for fun. Our b value is 2, so 2x, right? You do not need parentheses around 2x, but if you want to put it, it is fine. And then minus 1 because we've gone 1 unit down. So 2x minus 1. The cotangent of 2x minus 1. Okay, let's check out our last one. All right, looking at this crazy looking graph, what would you say the trig function is that has this as its graph? Okay, and because they're u's, hopefully you would say it's either a secant or a cosecant graph. And then based upon that, because we have a u on your x-axis, hopefully you would know that this was going to be a secant graph. Okay? Because the u is centered on your x-axis, this is going to be a no phase shift secant graph. Okay, so let's identify where are the asymptotes. The asymptotes are in between your u's. I should really look up and see what the actual name of these u's are. I just keep calling them u's, because that's sort of what they look like. Okay, so those are the asymptotes right in the middle, right? Because your vertical sides of your u's don't cross your asymptotes. So it looks like we have an asymptote at negative pi and at positive pi. So how far is it from negative pi to positive pi? Exactly 2 pi. Okay? And like I said up here, right, for our cosecant and our secant, we need to have 2 u's to make up the entire period. So if I only have 1 u, that's going to be half of my period. Okay? So that means that half of my period equals 2 pi. So if half of my period equals 2 pi, what does my entire period equal? 4 pi, right? We have to multiply it by 2. So 1 u is only half of your period. That's half of your cycle. So we have a period of 4 pi. Now the b value is always just 2 pi. Our standard period for secant and cosecant is 2 pi. So what is 2 pi divided by 4 pi reduced to? Right, the pi and the pi divide out. 2 divided by 4 reduces to 1/2. Okay, so we don't multiply by the reciprocal because we're not dividing by a fraction. It's just 2 pi divided by 4 pi, which reduces to 1/2. Okay? Now, the maximum point, right? This right here, this is a local maximum. So the maximum point's going to come from your bottom of your U, right? So this is kind of the range, the negative infinity, and the maximum point is positive 1. Okay, so that's like the range of the bottom of your U, the bottom half of your secant graph. And then the minimum is going to be this point right here, which is the lowest point of the top part of your secant graph. And that's at 1, 2, 3. Right? So what we're actually doing is we're writing the range of your secant from negative infinity to positive 1, and then again from 3 to infinity. Okay? So that's what these ones are going to be like for a secant and or a cosecant graph. Okay, your vertical slide is where is the middle, the very middle of your U's, right? So it's in the middle here. Looks like there's 2 units between the top of my U and the bottom of my other one. So we have a vertical slide of up 2 units. The middle, right? So the midline of this graph is 2 units above the x-axis. It's traditionally on the x-axis. This has been moved 2 units above. Okay. Now there's no phase shift because we have a U exactly centered on your y-axis. So we don't have any phase shift for our secant graph. Now if you wanted to write a cosecant graph, yes, you would have a phase shift, but not for a secant graph. And since secant is easier, that's what we do. Now our dilation. Okay, the dilation is the last thing we should talk about. The dilation for this is the distance between your midline and your minimums. Okay, so this has a dilation of just 1. Okay, so all of these alternate graphs, secant, cosecant, tangent, and cotangent, they all have a dilation rather than an amplitude, a dilation factor. Okay, so between your maximum point and the midline is your dilation. These graphs have a dilation of 1. So in other words, there's not going to be a number in front of secant. Okay, so you don't have to write a 1, so I'm just going to erase it because it's not supposed to be there. Okay, secant of, here's your b value, 1/2 of x. And since we don't have a phase shift, you can put that whole thing in parentheses if you want to. But of course, not having parentheses is also acceptable. And then we have your vertical shift of up 2 units, in other words, plus 2. Okay, so you can have secant 1/2 x plus 2, or you could have the 1/2 x in parentheses. Both of those things are the same. Okay, so it's important to understand what information are we looking for to justify one entire period. For tan and cotan, that's just one set of asymptotes, right? One pair. And for cosecant and secant, it's 2 pairs, giving you an entire upward U and an entire downward facing U. All right, sounds good. Have an awesome and excellent day. Goodbye.